All right. Hello, Algebra 1. Welcome back. We are continuing talking about solving quadratics this week. We are going to learn a new method of solving a quadratic. But let's first rehash our different methods that we've talked about so far. So we have three methods that we've talked about so far on how to solve quadratics. The first one was factoring. Factoring was our first method. So with factoring, we always had to use the box and the diamond method, or box and your x, and we had to figure out what each of those factors were that were equal to our problem, and then we set each of those factors equal to 0, and we solved them, and that's how we got our solution. So you had to factor your quadratic, find those factors, set each of those factors equal to 0, and then you were good. Sometimes we couldn't factor, or sometimes rather than factoring, it was easier for us to solve using square roots. So solve using square roots. This is what we looked at last week. So sometimes you had to solve using square roots. It was more of like an equation. We had to pull apart the pieces on the outside of the equation, inverse some of those operations to get to where we could get something squared equaled some number. So you could take the square root of one side, take the square root of the other side to inverse your square. And we got that answer equal to some square root of something, and then you were able to solve from there to get x equals. Now, sometimes this gave us nice answers, sometimes this gave us ugly square root decimals, and we learned to work with both of them. Sometimes we got good ones, sometimes we didn't get them. But we could only do this if we didn't have all three terms. If we had all three terms, we had to factor. If we didn't have all three terms, we could solve by square roots. And then another method we've used kind of mainly to really check our answer, but we can also solve quadratics by graphing. So if we create a graph of the quadratic, we can see where that quadratic crosses the x-axis at those points. So we can see where those solutions are for our quadratic at whatever those x-intercepts are. So those were the three methods that we've really gone over so far with our quadratics. Now we are going to learn a new method. Now this new method that we're talking about today called the quadratic formula. The best part about the quadratic formula is it can be used anytime. It doesn't matter what the quadratic looks like. It doesn't matter whether it has 3 terms, whether it has 2 terms, or whether you can factor it, whether you can't factor it. It doesn't matter. You can always use the quadratic formula, which is the best part about this. So jumping into our quadratic formula, this is what it looks like. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now this is our big, ugly quadratic formula. Let's try to break this down into what it represents. What does it actually mean? Because right now this is just a bunch of letters and a bunch of, I don't know, gishkaba. I don't know what that means. I don't know what this is. So let's try to break this down. So when we are solving quadratics, we know we always have to have it equal to 0. So it needs to be in that standard form. Ax squared plus b. That's not a b. Let me use the lowercase letters. Let me be consistent. I'm sorry. Ax squared plus bx plus c equals 0. That's our standard form of quadratic. A, b, and c. Now, it always has to be equal to 0. So we always essentially, the first thing you always need to do whenever you're doing the quadratic formula is get everything equal to 0. So get everything on one side. And then we have to look, okay, what is our A, what is our B, and what is our C of our problem? So you're always solving for x. So this x equals part isn't necessarily important. But we always will need to figure out what is your A, what is your B, and what is your C of your problem. Because those are going to be the numbers that you are going to be filling in your quadratic formula. So opposite of b just means you're going to take the opposite sign of whatever b is. B squared means you're going to take this, you're going to do b squared. Negative 4ac means you're going to do 4 times whatever number is a times whatever number is c, and then divided by 2a, you're going to do 2 times a, obviously. The plus or minus, this is kind of like when we took the square root. So when we were taking square roots, we saw that square roots had 2 solutions. You had the positive solution and you had the negative solution. So this plus or minus shows that we can get 2 solutions for these quadratics because we're taking the square root in part of the formula. So that's why there's that plus or minus there. So remember, at some point, you may have to split this into 2 separate problems, one with a plus, one with a minus. Luckily, this is a lot to have to remember. Luckily, there is a little mnemonic thing that we can do. There's a little song that we can sing to remember it. And it goes something like this. X equals the opposite b plus or minus the square root b squared minus all over 2a. And that's our little song. So I will sing that frequently to you guys. I hope you don't get too annoyed by me, but it's fair if you do. I understand. If not, I can get Mrs. Ruprecht to come over. She can sing it to you as well, if that makes you feel better. But you can use that song to help you memorize this. You do not have to have this memorized for your state test. It is on a formula sheet given to you, but it is very, very handy to have it memorized. The easier it is to have it, or the easier it is you're more familiar with it, the better it will be for solving. So let's look at some solving questions. Let's look at how we can write this out. So I have the quadratic formula here up at the top, just in case you need a refresher at it. But let's start with this one. So we have 2x squared plus 8x minus 10 equals 0. So luckily it's already luckily it's already set up for us nicely. It's already set equal to 0. So we don't have to worry about that part. We will have to change that a little bit later on in some of the questions. But the very first thing we always want to do is we always want to say, what is my A, what is my B, and what is my C? So A in this question is 2. B in this question is 8, and C is negative 10. I want to make sure I'm paying attention to positives and negatives with my numbers. So I had this minus 10, so it's going to be a negative 10. And then from there, I can start filling in my quadratic formula. So I know it's the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. So I'm just going to take this formula right up here, and I'm going to start filling in these numbers in for those pieces. So I'm going to start with the opposite of B, which is going to be opposite of B. If I have positive 8, I need negative 8. Plus or minus the square root of b squared, so 8 squared, minus 4 times a is 2 in this case, times c, which is negative 10. Now, I sometimes write these in parentheses, sometimes you don't. Just remember that all of these three terms right here are being multiplied. So it's negative 4 times 2 times negative 10. So that negative is with that 10. All over 2 times a. Now, typically, we have this x equals here, but I always know my answer is going to be x equals. We're solving for those x-intercepts, those solutions, those roots, so it's always going to be x equals at the final part. So if I don't write this x equals part, that's why. I'll write it at the very end, but it's not necessarily important for solving the quadratic formula. So now that we have this all written out, now we can start going about step by step to solve it. So if we think through order of operations, we need to use order of operations in order to sort of simplify this in order to solve it. So order of operations, the first thing is parentheses. Parentheses is also known as grouping. Well, everything under the square root is all one group. So we need to simplify all of that part under the square root first. So I have negative 8 plus or minus the square root all over 2 times 2. Well, what's all this happening in the square root? Well, 8 squared, I know what that is. 8 squared is 64. And then I can do this multiplication part in here as well. Negative 4 times 2 times negative 10. So negative 4 times 2 is negative 8. Negative 10 times negative 8 is 80, but it's positive 80. So I have 64 plus 80. So typically I simplify the square root part, or I simplify the square part, and then I simplify that multiplication piece. And I put that all in the square. And 2 times 2, I actually know what that is as well. I'm going to simplify that as well because it's easier to write. That's just 4. So in our first step, we square, multiply, and then multiply at the bottom. And so we can write that part. So negative 8 plus or minus the square root of 64 plus 80 over 4. Now from here, I still need to figure out what this is. I can't take the square root until I figure out what that number is. So what is 64 plus 80? Well, 64 plus 80 is 144. So I have negative 8 plus or minus 144 over 4. So already this is looking like a much scary problem to a nice, easier problem. What is the square root of 144? Well, square root of 144 just turns out to be 12, so we can add that in here. So we have negative 8 plus or minus 12 over 4. And now here, this is where I'm going to need to split my question into two parts. This is where I'm going to need to split my question into the two different pieces. Because I have negative 8 plus or minus 12. Well, I need to split it into a negative 8 plus 12 and negative 8 minus 12. Because once again, when I take the square root of a number, there's two solutions. There's the positive solution and the negative solution. So we are going to split this into negative 8 plus 12 over 4. And then negative 8 minus 12 over 4. Well, what's negative 8 plus 12? Negative 8 plus 12 is just 4, so this is 4 over 4, which turns into 1. So x equals 1 is one of my solutions. Negative 8 minus 12 is negative 20. Well, what's negative 20 over 4? Negative 20 over 4 is negative 5. So x equals negative 5 is my second solution. And those would be my two solutions to my quadratic. Once again, when we're solving quadratics, we have the possibility of getting 2 solutions, which is most common, 1 solution, which happens sometimes, or sometimes I get even 0 solutions. There's no solutions to the quadratic. I don't think we'll see any of those today, but it's possible. So those are my 2 solutions for my quadratic. X equals 1 and x equals -5. And that is our quadratic formula. Let's look at another example. So I have x squared minus 4x equals -1. Now I need to remember, I always need to have it equal to 0 to start with. So this equals -1. I don't like that. I want to get rid of that. So I'm going to add 1, just like what we would with our factoring questions, to get it all equal to 0 on one side to start with. Now this 1 here doesn't go with my x squared. It doesn't go with my -4x. So I'm just going to put it at the end because it's a constant value. And it didn't have any like terms. So I have x squared minus 4x plus 1. And now that I have my full trinomial, my full quadratic, I can then write down what is my a, b, and c. So a, well, what's the number in front of this x squared? There's no number, so it's just going to be 1 because it's that hidden invisible 1. What's the number in front of my b? Well, that's -4. And then my c is going to be just a positive 1. So a is 1, b is -4, c is 1. Those are my numbers. Now with that a, b, and c, I can start filling in my quadratic formula. So opposite of b plus or minus square root b squared minus 4ac all over 2a. So that's our quadratic formula. So I have the positive 4 because it was a -4 plus or minus -4 squared. I want to make sure that negative is in those parentheses. The reason being because -4 times -4 should give us a positive number, while if I leave that number without those parentheses, if I did 4 squared then added the negative on there, that's going to give me a negative number. So that's 2 different solutions. So I need to make sure that negative is included with my parentheses being squared. Minus 4 times 1 all over 2 times 1. All right, so we know we always need to simplify the square root part first. So I'm going to simplify what's under my square root. So I have 4 plus or minus the square root of, what is -4 squared? Well, it's -4 times -4, which is positive 16. And then -4 times 1 times 1, well, -4 times 1 is 4, times another 1 is just still -4. And then all over 2 times 1, which is just 2. So I've simplified all those multiplication and square root parts. Now I can start combining things. So square root of 16 minus 4. Well, what's 16 minus 4? That's going to give me 12. So I have 4 plus or minus the square root of 12 over 2 so far. Pretty easy, pretty simple so far, going smooth. Well, here's the thing, though. In my last question, I had the square root of 144. That was easy. Square root of 144 is just 12. But what is the square root of 12? If I plug the square root of 12 in my calculator, I do not get a perfect square. It is not a perfect solution. So this is where we have to think back. Before we started solving with quadratics, after we learned about factoring, we did a quick lesson about solving or simplifying square roots. So simplifying square roots. So if I have the square root of 12, I need to simplify this in order to solve it, because I do not want to have to deal with a decimal. I don't want to have to deal with 3.2 something something, whatever the square root of 12 is. I don't want to have to deal with this decimal. I want to keep this as simplified as possible. So I need to simplify this square root, simplify the square root of 12 in order to help me continue on with this problem. So simplifying the square root of 12, square root of 12, 12 splits up into 3 and 4, which I know splits up into 2 and 2. I have a pair of 2's here, so I can circle it, cross one out, and then I know that I'm going to get a 2 on the outside of my problem, and then this 3 did not have a partner, so this 3 is stuck inside my square root. So square root of 12 simplifies into 2 radical 3. So once again, we're using that exact same steps we were simplifying square roots before. So this is 4 plus or minus my 2 radical 3 that I got for the square root of 12, all divided by 2. Now, once again, when we have a radical number, when we have a normal number, like a whole number, like 4 and 2 radical 3, these cannot combine because that radical is not a like term. If I want to keep this simplified, I cannot add that irrational number to a rational number. I cannot add that radical in. So I can't add these together. So there's no reason necessarily to split this up into 2 problems of 4 plus 2 radical 3 and 4 minus 2 radical 3. It's just going to be the same thing with a plus or a minus in there. How I can simplify this, though, if I look at the outside numbers, so my outside numbers are 4, 2, and 2. If I look at all these outside numbers, if all 3 of these outside numbers, all 3 of them are divisible by the same thing, then I can simplify it by simplifying that fraction. So 4, 2, and 2 are all divisible by 1. Or sorry, that's terrible. 4, 2, and 2 are all divisible by 2. So I can divide each of these numbers by 2. So I'm going to simplify this fraction by dividing 4, 2, and 2 by 2. So 4 divided by 2 turns into 2. 2 divided by 2 turns into 1. And 1 divided by 2 turns into 1. So this is 2 plus or minus 1 radical 3 over 1. Now, when I divide by 1, I'm not really doing anything. So I don't really have to write that divide by 1. And the 1 in front of my radical 3, I don't really have to write either. So this is technically 2 plus or minus radical 3. And this is the simplified version of this fraction. Now, once again, this represents two different solutions. It's 2 plus radical 3 and 2 minus radical 3. Now, do I care what those decimals are of 2 plus radical 3 and 2 minus radical 3? Not really. What I do care, though, is I want to get that simplified solution. So this is my most simplified x-intercepts, or my most simplified solution for this quadratic. And that would be where my quadratic is on problem. Let's see. Okay. All right. I'm running out of time. These problems take I'm going a little slow on these problems. So I'm gonna skip this next one. I'm gonna jump to this, and we are gonna do. We'll jump a little bit to both of these. Okay. So this first one, once again, x squared equals 7x. Now, equals 7x, I don't like that part, so I'm going to move that 7x over, because once again, I need everything equal to 0. So I have x squared minus 7x equals 0. Now, if I look at this question, that's all my parts. That's all I have to this. So if I do A, B, and C to this question, I get A of 1, because there's just a 1 in front of there. I get a B of negative 7, and a C, my C is just going to turn out to be 0. So when I fill out this problem, I'm going to have a 0 as my C. So some of that stuff isn't necessarily going to be treated as normal because I'm going to be multiplying or adding by 0. So when I fill out that opposite of B, plus or minus square root, all that fun stuff, I'm going to have 0 show up in that. I'll let you solve through that question if you'd like. You can pause the video and you can solve through it. I believe your answer should be 0 and 7 are your two solutions. But I'm going to look at this one over here. So if you want to go back and solve that question, feel free. So with this one, we have two pieces on each side. So once again, it's easiest to get everything over to one side. So I'm going to get everything over to my x squared side. I like that best. So I'm going to add this 8x over, and I'm going to add this 1. Now, I'm essentially doing two steps in one. I'm inversing two things in one. So 8x doesn't add to either of these, so that's going to be 3x squared plus 8x plus 2. But this 1 adds to 2, so this is actually going to be a plus 3. And all of this is going to be equal to 0. Now, once again, from here, once you get everything equal to 0, we can start inversing, or we can start writing down what is my A, what is my B, and what is my C. So A in this problem is 3. B in my problem is 8. And then C in my problem is 3 as well. So if I start writing out my quadratic formula, opposite of B plus or minus the square root B squared minus 4AC all over 2A. So we got our quadratic formula written down, and then we can start going to solve it. All right, looking at this, I have negative 8 plus or minus the square root of 8 squared minus 4 times 3 times 3. If you want to, honestly, you could actually type this whole thing into the calculator. You could do negative 8 plus square root of 8, blah, 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 or you could do negative 8 minus that. And you could type both those things into the calculator, and it will give you the solution, because once again, we're just simplifying this. It will give you both those numbers. That should work, assuming it comes out to a whole number. Sometimes it might not simplify very nicely, though, like that last question. So if we have negative 8 plus or minus the square root of 8 squared, is going to give us 64 minus 4 times 3 times 3, which I believe is 36. So that's negative 36 because it's a negative 4 times 3 times 3, all over 6. Well, what is 64 minus 36? This gives us negative 8 plus or minus the square root of, what's that number? That turns into 28. Radical 28 over 6. Scrolling down still. So negative 8 plus or minus radical 28. Well, radical 28 doesn't have a solution. What is the radical 28? Radical 28, if we simplify, that turns into 4 and 7, which can be split into 2 and 2. If we circle that, cross one out, that's 2 radical 7. So radical 28 doesn't simplify normally, so we're going to turn it into 2 radical 7 because it's not a perfect square. So this is negative 8 plus or minus 2 radical 7 over 6. Now, once again, I can't go any farther than this. I can't add negative 8. I can't split this in, I can't split this into two problems, but I can't add negative 8 to 2 radical 7. I can't subtract negative 8 from 2 radical 7. So what I'm going to do is I'm going to look at those three numbers once again, -8, 2, and 6. What are they all divisible by? Well, these are each even numbers. So if I can divide them all by 2. So 8 divided by 2 is 4. 2 divided by 2 is 1. And then 6 divided by 2 is 3. So I could rewrite this as -4 plus or minus. Now, 1 radical 7 is really just the same as radical 7. I don't have to write that 1 there. And then this turned into 3. So this would be my final solution. X equals -4 plus or minus radical 7 over 3. Now, obviously, that doesn't look like a very simplified solution, but that is as simplified as we can get it with our math currently. We cannot simplify this any further with that radical in there. You can just write it, leave it with the plus or minus. Technically, it's two solutions because one's plus and one's minus, but you can just leave it as a plus or minus. That is still correct. And that is where we'll leave it as that simplified so far because we can't simplify it any farther because of radical 7. So that's where we'll end the video today. You're going to have some time practicing over these. You'll have some time organizing the steps, being able to work out these on your own, listen to me hearing a song, all those fun stuff. So if you're curious for hearing me sing the song anymore, let me know. I will gladly sing it to you 100 times over. So that's our quadratic formula. Have a great rest of your day.